Now let's see the effect of concentration on rate of reaction. Now concentration measures, it is a measure of the amount of substance that is present in a certain volume. Now amount of substance is measured in moles, and volume, a fixed volume, normally the volume that we consider is in dm cube. So concentration is usually given in mole per dm cube or gram per dm cube. Even if they are not equal units, the 1 mole per dm cube is not equal to 1 gram per dm cube, but the concentration will give you, the value of the concentration will give you an idea of how much particles there is in a certain volume of that substance. So for example, if you take, here you have a concentrated substance, so high concentration. So as you can see, there is a lot of particles in the same volume. Here this is of a lower concentration, so there's fewer particles in a certain volume over here as compared to here. Now if you look at this example here, so you have a concentrated solution. So concentrated sugar solution, there's many sugar molecules and few water molecules. So these are particles of sugar particles, and here as well. So these are sugar particles, solute particles, and you see there's a lot of solvent and small amount of sugar. So this is a dilute solution. So here concentration is low, as compared to here where you have concentration is high because you have lots of sugar particles and small amount of water particles, concentrated and dilute. So the concentration gives you an idea of how many particles are there in a certain volume. So the volume is the same in both solution, but here you have more sugar particles. So when you have lots of particles, definitely more particles mean more collisions. If there's more collisions, means there's going to be more effective collisions, so rate is going to be faster. Low concentration, you have fewer particles, fewer effective collisions, slower reaction. So what happens is that when concentration is high, rate is high. When concentration is low, rate is low. So concentration is directly proportional to rate. So when concentration is high, rate is high. When concentration is low, rate is low. So they are directly proportional. So explain why rate of reaction increases when concentration increases. When concentration increases, there's more particles occupying a given volume. The frequency of effective collisions increases and the rate of reaction increases. Okay, so there's 3 elements of answer here. 1, 2, and 3. Now let's see one example. So you have the gas produced from a 1 mole per dm cube hydrochloric acid with magnesium is given. You have to sketch the graph for a reaction of 2 mole per dm cube hydrochloric acid. So this is dilute, this is more dilute, and this is more concentrated. So if it is more concentrated, means that the rate of reaction is going to be faster, which also means that the reaction will end in less time. So time taken for the reaction to take place is going to decrease. So reaction will be faster. Okay, so how would you sketch the graph? So if we look at this graph here, this is the point where the reaction is over, which means that with 1 mole per dm cube, reaction is over in this amount of time. Now, if we do the reaction with a higher concentration of hydrochloric acid, the reaction will be over in less time. Here, so it will be over in less time. Now, the initial rate is going to be faster, which means that the gradient is going to be steeper because rate is greater. Remember, rate is proportional to the gradient. So here it's going to be steeper, and it ends in less time. The total volume of gas, total volume stays the same. Why it stays the same? Because you have, normally if you have the same amount of magnesium, it will stay the same. If you use more acid, let's say you use in this one, in the first reaction, you use 50 centimeter cube of acid, and in the second one, you use 100 centimeter cube of acid. So if the volume is more, then you will have more product. But if you have the same volume, same amount of reactants, you will get the same amount of product. The amount will stay the same, but it's just the rate that is going to be faster or slower depending on the concentration here. Okay, so let's watch a video that shows this reaction. You're going to complete the fill in the blanks and try to explain why reaction slows down as time goes on. Okay, so as you can see here, there's two tubes where you have the same volume of acid being transferred to the boiling tube, and in tube A you have dilute acid, while in tube B you have concentrated hydrochloric acid. So in tube B, you see that the reaction is more vigorous. So there's more effervescence, there's more foaming that is taking place. So here you can observe in tube A how the bubbling is taking place. And you have hydrogen gas which is being produced. So here you have the chemical reaction that takes place. Magnesium with hydrochloric acid giving magnesium chloride, which is in solution, and hydrogen gas, which is escaping. Now, when you use concentrated hydrochloric acid, the hydrogen gas is formed faster, so the rate of formation of the gas is faster. So you have more particles per unit volume in a concentrated solution.